Welcome back. In this video, we're going to take a quick look at for loops. We use for loops to solve a common problem in Java in a very semantically elegant manner. For loops are appropriate when we're going to be iterating a variable to count how many times we've looped. To start us off, I've written a very basic program using a while loop. It prints the values 1 through 100 to the window on our screen. Once you've hashed out in your mind how this while loop is working, now we're going to write the same loop with a for loop so that we can see how the for loop is more elegant in this particular instance. Let's comment out our while loop so that we can still see it without having it execute any of its code and begin writing our for loop instead. The basic syntax for a for loop looks very similar to a while loop. We have the reserved keyword, 2 parentheses in which we'll put some information that the loop needs, and then the code block that we're going to loop through. Unlike a while loop, which just takes a conditional statement between these parentheses, we're going to provide our for loop with a bunch of information. Because the for loop is designed to handle a specific case, once we give it all this information, it will know exactly what to do with it. This alleviates the need for us to handle code outside of the loop and manually increment or decrement inside of the loop. It keeps the functional bit of our code, our print line statement, and in more complicated programs, the more complicated information that may be here, more isolated. Our typical for loop takes 3 pieces of input. First, we need to declare the variable that we're going to be incrementing or decrementing to count the number of times we've looped. In this case, we'll use an integer I, and we'll give it an initial value of 0. We follow this initial statement with a semicolon. This is not a function call, it's special syntax for the for loop. The second piece of information the special syntax requires is the conditional statement that we need to evaluate each time we're going to restart the loop. If this conditional statement is ever not true, then our for loop ends and we continue resuming our code after the for loop block. In this case, our conditional statement will be the same as it was for the while loop. We want our last iteration of the for loop to be when I is equal to 100, when we'll print out 100. Once I is no longer less than or equal to 100, it's time to exit our for loop. Just as the first piece of information we specially gave the for loop saved us from having to handle a variable outside the scope of our loop, the last piece of information we give the for loop takes the place of us having to manually increment or decrement our counter inside the scope of the loop. This is the modification special code, and whatever we provide the for loop here will run at the end of every loop. In this case, we'd just like to increment the value of I at the end of each looping through. I think you'll agree that this program is much cleaner than our while loop. Now, let's just check that it performs the same task, printing the value of 1 to 100 to our screen. Oh, I actually made a mistake here. We started our I off at 0 instead of 1. Now we will print the value 1 to 100 to the screen. Were this statement to execute at the very beginning of our for loop, the 0 would have been correct, but this executes at the end. When we're working with large numbers and incrementations in Java or any programming language really, we call errors like what we just ran into off by 1 errors. Off by 1 errors are those kind of little logic mistakes that even experienced programmers can run into if they're not paying attention or just look the wrong way for an instance. Learning to recognize the symptoms of off by one errors, for example, one more line outputted than expected, will allow us to track them down and find them much more efficiently. Thanks for watching.